Hi everyone, and welcome. Have you ever wondered if there's a quick way to add up the first in natural numbers, like 1 plus 2 plus 3 all the way up to n? Today, we're going to derive the famous formula for this sum, s equals 1 plus 2 plus n, using a really intuitive geometric picture. Let's represent this sum, Sn, visually. Imagine we have building blocks, or squares, each with an area of 1. We stack them up, 1 square in the first row, 2 in the second, 3 in the third, and so on, until we have n squares in the nth row. Point to rows as you describe them. Look at the shape we've created. It's like a staircase or a rough right triangle. The total height is n units, and the base width is also n units. Since each square has an area of 1, the total area of this entire stack is exactly the sum we want to find. Sn equals 1 plus 2 plus n. Now, let's overlay a large right triangle onto our stack. We'll draw an isosceles right triangle with a height of n and a base of n. What's the area of this large red triangle? The area of any triangle is 1/2 times base times height. So, for our red triangle, the area is 1/2 times 1/2 times n equals 1/2 n squared. Let's write that down. Area of big triangle equals 1/2 n squared. Notice how this triangle covers most of our stack, but not perfectly. Where does our stack differ from the red triangle? Look closely at the squares along the steps. The red line cuts through each of these squares. The part of the square inside the red triangle is accounted for in the 1/2 times n square area. But what about the parts of the squares outside or above the red line? Each of these is a little right triangle. Since the red line cuts diagonally through a unit square, 1x1, it divides the square into 2 equal triangles, each with an area of 1/2. How many of these little, extra, triangles do we have? There's one for each row, from row 1 to row n. So, there are exactly n of these small triangles, each with an area of 1/2. The total area of all these small triangles, combined is n times 1/2. Let's note that area of small triangles equals 1/2 times n. Now we can find the total area of our original stack of squares. The stack's total area, Sn, is simply the area of the large red triangle, plus the total area of all those small triangles sitting above the red line. Substituting the areas we found, Sn equals 1/2 times n square, plus 1/2 times n. We can make this look neater by factoring. Both terms have a 1/2 and an n in common. Let's factor out 1/2 n. That gives us Sn equals 1/2 times n plus 1. And there you have it. Using this geometric picture of squares, a big triangle, and little triangles, we've successfully derived the formula for the sum of the first n natural numbers. This elegant formula is incredibly useful in many areas of math and science. Try it out for yourself. Thanks for watching.